Good to be with you all today. Thanks for joining us. We'll start off just by talking a little bit about what types of projects benefit from this method of linear scheduling. You can see that projects that are long in nature with a horizontal alignment, like tunnels, roadways and bridges, railways, transmission lines, all of these projects are stretched out over location, over long distances, pipelines, and also vertical projects such as a high-rise building. And the thing that these types of projects have in common is the work activities, the construction crews move over time from one part of the project to another. And projects that have those kinds of activities that move like that are something that you can illustrate by time and location and help people see how the work will move. So maybe a little bit of time to compare how linear scheduling compares to traditional scheduling or Gantt charts. Many of you have seen schedules that look like this. And the larger the project, the larger the schedule, right? Some projects have thousands of activities on many, many pages. Very difficult to read. Too much information for the boss. It doesn't really show us how things move. It's more like just a list of activities. And it's hard to see where people are working. And sometimes tools like this are mostly used for paying the contractor for their work if it's a cost-loaded schedule. But on large projects, it's very difficult to actually plan the project in this format because of the way that people can't see it very well. So I believe that the project teams that we work with really, really do want to know what is in these schedules. But there's just a lot of barriers. It's very difficult for them to get this information out of the schedule and communicate it to people. So that's partly what we're going to be discussing today, is another way that we can communicate this information in a way people can see and understand. Aldo, would you like to speak to this slide?
Yes, I will speak about it in Portuguese. Essa aqui é a maneira mais tradicional de se mostrar um cronograma. É o nosso famoso cronograma de barras. Suponha que a gente vai fazer um edifício de 3 andares. E aí eu tenho a estrutura, a alvenaria e os acabamentos. Tá? Eu criei aí a rede de precedência, bastante simples. Just one second, James. E vocês podem ver que, embora esse gráfico aí mostre a sequência, mostre todo o escopo, mostre o fluxo de serviço, ele é muito pouco visual. Aliás, esse prédio aí, se você olhar, está estruturado do andar 1, embaixo vem o andar 2, embaixo vem o andar 3. Enquanto na vida real, um prédio está ao contrário, está de cabeça para baixo. O primeiro pavimento vem embaixo, o segundo vem em cima. Então, olhem o que eu vou fazer aí. Go ahead, James, please. E esse é o mesmo exemplo, só que agora eu coloquei do lado o edifício e na coluna vertical, no eixo do Y, eu botei aqui, na verdade está ao contrário aqui, é floor 1 é embaixo, floor 2 é no meio, floor 3 é em cima, mas você vê as atividades agora elencadas sob uma forma que pode ser unida através de uma linha. É por isso que na literatura nós encontramos a terminologia linha de balanço, line of balance. Balanço é ritmo em inglês, tá? É como se fosse uma linha mostrando o ritmo no qual aquelas atividades irão ser executadas. Go ahead, James, please. A inclinação da reta mostra a produtividade daquele serviço. Go ahead, James, please.
Okay, so here is a simple tunnel project. It has 2 work sites, 2 shafts, and a tunnel that connects them. A traditional Gantt chart or bar chart schedule would look like this. We prepare the site at the south, construct the south shaft, prepare the north site, construct the north shaft, assemble the tunnel boring machine, excavate the tunnel for about a year, retrieve the tunnel boring machine, punch list the project, and the completion milestone.
Just one second, James. Let me quickly explain. Isso aqui é túnel. Ele tem um emboque, o desemboque e a escavação do túnel com uma tuneladora. Todas as atividades estão presentes aí. Mas se você olhar, é difícil de ler isso aqui. So now James will present this same schedule in another format. Go ahead.
A lot of times on projects like this, because the schedule does not show location, engineers will create another chart like this with the tunnel stationing here, the location, and the time. And you can draw the activity of the tunnel boring machine moving. You could also show more detail with a learning curve to start, stops along the way for maintenance, things like that. So what we're going to do is combine this simple chart with some of the other activities from the first schedule. Here's a 1-page setup for the linear schedule. Time is from left to right in this example, and location is vertically. Now we're going to plot all those same activities on this XY coordinate system.
Como vocês podem ver, todas as atividades estão aí, só que agora você consegue ver para onde a equipe está pulando, where the crew is going from one side, from one point to another one, e vocês podem também ver a obra espalhada ao longo da extensão, aqui no caso do túnel. Estão entendendo? Vão dizendo sim ou não, por favor. James, go ahead.
Yeah, so the advantage of this format is you have all of the information now on one page, plus a picture of the project to help people understand what you're building.
And you can quickly answer, for example, when am I going to be at station 65? You just have to go to 65 and you very quickly derive, it will be in October 2018 and so on.
So the types of shapes that you saw on this linear schedule are a line that has 2 locations and a start location and a finish location. A block shape is like we used for the punch list activity. For example, if you don't know where everyone's going to be to do all the quality control checks at the end of the project, we just blocked out that period of time across the whole alignment of the project. A bar activity is for work at one location, for example, the shafts, and then a milestone is your end date. Let's do one more example with a simple bridge. 3 spans on this bridge, 2 piers and 2 abutments. So this time we're going to plot time vertically from bottom to top. We're going to build it from the ground up like we build a bridge. And location is on the x-axis. We start with the foundations. Then we pour the concrete piers and abutments. We place the girders for each span. Pour the concrete deck. Grouting and post-tensioning to complete the deck. A topping slab for the roadway driving surface. And the align to represent the completion deadline. So again, this is a simple example, but you can see the whole sequence on one page.
E aqui, and here, you can see in what direction the crew is working. Aqui vocês podem ver que nós estamos avançando do sul para o norte. Qualquer pessoa é capaz de entender essa ferramenta. Isso é muito importante para apresentar de uma forma sumária aquele cronograma de 200 ou de 1000 atividades. Outra coisa, qualquer pessoa consegue ler, né? E você consegue saber o zigue-zague, o pulo que as equipes vão dar ao longo da obra. Go ahead, James. Oh, there is another. Could you move back one slide, please? And here, according to the slope of the line, de acordo com a inclinação da linha, você consegue deduzir qual é a produtividade daquele serviço. Então, se você olhar aqui, ó, o deck de concreto vai de meados de fevereiro ao final de março. Eu vou levar 45 dias para fazer aquilo tudo. Já a laje, que seria aí o pavimento da ponte, ela é mais rápida, ela leva menos tempo. Ela começa no primeiro dia de maio e termina na segunda quinzena de maio. Tá? Então, isso tudo você se beneficia com esse aspecto visual que, num cronograma gigante, assusta qualquer pessoa, porque ninguém consegue ler. Só o autor do cronograma consegue ler o cronograma gigante. Go ahead, James, please.
I will go through this one a little bit quicker here, the pipeline. So you have a long pipeline buried, and here is a simple Gantt chart. You start with grading and pipe stringing to get the ground ready and lay out the pieces of pipe. The welding crew welds all the pipes together. The trenching crew digs the trench, and then a crew follows behind them to lower down the pipe into the trench and then backfill on top of it. And then one more crew follows them to do the restoration and the cleanup. And we also have a period of time here in the spring that we cannot do any work because of environmental restriction. So we're going to draw this with a linear schedule as well. Time is, again, from bottom to top in this example. And there is our shutdown window where we cannot work. The first crew moving will be the grading and pipe stringing. And you can see they started at the end of January and they advanced most of the way, but had to stop for 1 month where there was no work. So time is passing, but no work is happening. And then they can resume work and finish. The next crew is the welding crew. This takes longer, so the slope of the line is steeper, right? Trenching goes more quickly. The lowering and backfill operation follows right behind. And the restoration crew also follows right behind. So again, like Aldo, go ahead.
Yes. Pessoal, vocês podem ver que a linha verde, ele não poderia começar mais cedo, porque senão a linha verde iria cruzar com a linha azul. A linha azul é a solda e a linha verde é o assentamento do tubo dentro da vala. Então veja que o verde foi calculado para chegar junto do azul lá no final da obra, certo? Ele é meio que projetado de trás para frente. Se eu tivesse começado o verde em fevereiro ou março, eu iria cruzar com o azul, o que não pode, já que uma atividade aqui nesse caso depende da outra. Go ahead.
Okay, the last example of the simple kind here is a high-rise building. So everything that we've shown you so far has been infrastructure projects, like civil infrastructure, but there are contractors using linear schedules for vertical construction like this as well. So in a high-rise building where you have levels, there's a lot of repetitive work on each floor, right? Similar to the example Aldo showed previously. So we'll start at the ground level. We dig down with excavation and bracing to get down to the basements. Do the pile foundation, pile caps and the base slab. And then the structural work comes out of the ground and up with the columns, the beams, the floor slabs. This is all concrete or steel structure work. Followed behind them is the interior partition walls, utilities, glazing for the windows. That starts at the ground level, right, and goes up from there. Finishes, systems, landscaping at the ground level, and testing and commissioning. So this is an example of a vertical high-rise project.
Yes, if you had an activity coming from the top down, like for example, uma fachada, a facade, then the line would be in the opposite direction. Instead of from bottom up, it would be from top down. A linha estaria começando lá de cima e descendo. Tá? Isso se fosse uma atividade feita de cima para baixo, por exemplo, uma pintura de uma fachada externa. Go ahead, James, please.
Okay, so let's move into some examples from our projects that we've worked on. This was a project that I worked on for 5 years in Washington, D.C. That's the Washington Monument in the background, and this is the Potomac River. The problem was every year there is 2 to 3 billion gallons of combined sewer overflows into the river because the existing sewer systems there in the city cannot handle very large rain events. So our project was to construct a tunnel. Starting at this area, we dug a tunnel 4.5 miles up the river and up into the district. So these are shafts. This shaft here is a 132-foot diameter. I like to point out the size of the cars for scale. It's a very large hole in the earth. And we started this project in 2011. It was a 5-year design build project. And when we received the baseline schedule, it's similar to the problems I was explaining previously, where it's very difficult to understand in Primavera P6 printouts, right? We had 3,000 activities to look at, and we needed to understand it. So we put this into a linear schedule format, very similar to the first example I showed you of the tunnel. And all of these bars represent the work to construct the shafts that I just showed you in the photo. And then you can see there's shafts along the alignment at each location. So each shaft has a bunch of work at that location on the linear schedule to be built. And then the tunnel boring machine advanced over time from south to north. It's very useful, helped us understand the baseline, helped us work on several revisions, and also communicate it to the executives.
Right, and you see, for example, for this, go back, James, just please. You can see that the base in the middle, this BAFD, doesn't need to start in 2011. You can figure out when it will start, depending on when the TBM excavator will be in that station 120.
Exactly, yes. And we also plotted the milestones on this chart so that people can see when our deadlines were to, we had other contractors after us that had to follow on with more work. So we had to turn over these sites at each of these milestones. So we use that format to provide updates to the project team every month for the rest of the project. We produced an updated version of this whenever the schedule was updated. So my next major project, starting in 2016, I moved to this Alaskan Way Viaduct program in Seattle, which is where I live now. And basically, this is an elevated highway, very old structure. It was damaged in an earthquake and repaired, but it was a hazard. If there was another major earthquake, this structure could fail and could be public safety problems. So the governor required this to be torn down, and they came up with a solution. Instead of the viaduct along the waterfront, they decided to build a tunnel under the city to carry the highway. So here's an image of the tunnel. At the time when the project started, this was the world's largest tunnel boring machine project, 58-foot diameter, over 17-meter diameter tunnel boring machine was used. And there's roadways top and bottom, both directions. There's passageways for people to exit to safety. They can go out these doors and use this walkway here to evacuate if needed. Utilities in all these corridors, and ventilation is through this plenum here. So I joined the project in 2016, and it was right when they were restarting this tunnel boring machine to complete the tunnel under the city. So the orange line here represents the planned, the purple line represents the planned rate of advance to complete the tunnel according to the schedule when we started the restart. And the orange is the actual progress over time. So I updated this chart weekly, and we had data from the tunnel boring machine to know exactly where it was every day. And I put some notes on here for when we stopped to explain why we stopped. And you can see they performed very well. They were ahead of schedule with the completion of this tunnel compared to their advance rate. They did a very good job, and they also did it very safely under the city.
With the single image, you can compare the production rate, the purple, o roxo, é o planejado, the production rate planned versus actual, which is the orange one. And you can see period by period what the average production was. And you can see performance, you can see what happened, you can see when the tunnel boring machine broke. It's very neat. É muito claro, né? É uma peça de planejamento, de acompanhamento, de monitoramento para fazer um relatório muito melhor do que esse seu cronograma de barra de 1.500 atividades. Go ahead, James, sorry.
So there's the happy crew photo when they finished. After the tunnel excavation, this is the end of that curve that I showed you in the last chart. There was a lot more work to do to finish the project. So we had to build all of these structures inside the tunnel. So the crews would follow behind the machine to pour the concrete structures. And then we also have a lot of colored shapes here to represent all of the systems installations, mechanical, electrical, plumbing. All these yellow bars here represent the electrical rooms. There were 16 of those along the tunnel. Each room had a lot of electrical gear in it that controlled all of these systems.
As you can see, the yellow bar is horizontal because it's fixed in space. It's a station itself. So it's horizontal. The station is the same, and it takes time, okay? The inclined lines, as linhas inclinadas, are the services that are moving from one end of the tunnel towards the other end of the tunnel. As linhas inclinadas são dos serviços que vão de A para B, como ele diz, né? Do início para o final da obra. And you can see the green line that these two, can you point with the cursor, James? Yeah. Why are these two lines in the opposite direction of the blue lines? Can you understand? That's yes. Because they are coming in the opposite direction. They are coming from north to south. Why is it so, James?
Because at this time, in October of 2017, there was still a lot of activity here, and they wanted to get started on the deck, so they started early by starting it right there and working south. So they started behind and worked backwards, and you have to work backwards with the precast decks, because once you set it, you cannot drive past the precast deck. This is for the lower deck here. So you drive in, place the deck, and you back out, right? And then, so we did it backwards this way, and then came up here and finished backwards the other way. All the rest of this time here with these large block shapes, this is for commissioning, testing and commissioning time to complete the tests. Some pictures inside the tunnel. And here's bring in the concrete truck, and they pour cast-in-place concrete to pour the lower foundations for the walls to come up. There's the vertical wall forms, and all of these things travel through the tunnel. They roll on rails with the traveling forms. And the upper deck, this is cast-in-place concrete. So next example, after we have the tunnel, the tunnel kind of went underneath the city through here in this direction. Now we are ready to tear down the viaduct. And so what you see in this linear schedule is the plan for how to demolish the old structure. We started that demolition in February 2019. And in this example, time is from top to bottom. So we started at the north end with this crew moving this way over time, about 2 months. We also started here at Columbia Street and came down here to take out the ramp, and then a crew worked all the way across the central waterfront to there over time. There's a section of work right here that takes a much longer period of time, and that's because it was over the railroad. We had to saw cut and pick out sections of concrete very carefully because it was over the tracks, and that takes much longer. So you can see it takes the most time to complete.
If you take a look at the red arrow, you can see that they started here at the far left side, and then you can see where the crew went to the other end, right?
Correct.
If you can point that, yeah, from there, pam, 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 to there. You see? You can understand the flow. Você consegue entender o fluxo das equipes e do avanço da obra ao longo do tempo.
Some pictures. We used a couple different methods to demolish this viaduct, but most of it, with those red arrows I was showing you previously, are using these large machines that have jaws that crunch the concrete into rubble, and then it drops down and they haul it away in trucks. Zooming out a little bit, here's a photo of the whole waterfront after most of the viaduct is already removed. And now the city is currently working on rebuilding this whole waterfront to turn it into a much more attractive park. It'll be similar to like the New York City High Line, very nice architectural features, a lot of places for people to stop and enjoy the view. There will still be a major city street along here, but it'll be much more friendly to the neighborhood, and just a very great improvement for the city so far. So I think the next one is yours, Aldo.
Yes, I will continue in Portuguese, ok?
Yeah.
Isso aqui, senhores, meus colegas, é uma estrada, ok? Vocês podem ver aí que é uma estrada na Bahia. Como é que eu leio? Aqui embaixo está a estrada, quilômetro, sei lá, 21 a quilômetro 27, é um trecho pequeno. Na vertical está o tempo, tá? Isso aí são dias decorridos. Por onde eu estou começando a obra? Essa linha verde escura aqui embaixo. Você vê que eu estou começando aqui no dia 30, no dia 15 e avançando para a direita. Porém, no dia 50, se você vier aqui para o final da direita, você vê que eu estou abrindo uma outra frente do mesmo serviço, vindo no sentido oposto, certo? Essas barras verticais lilases aí são pontes, tá? São pontes que estão sendo feitas. O azulzinho, as barrinhas azuis menores, são bueiros. E assim você consegue rapidamente identificar a produtividade, onde cada equipe vai estar ao longo do tempo, se há conflito entre as atividades, um determinado equipamento vai entrar em cena quando. É muito mais fácil você localizar nessa folha sumária do que num cronograma gigante que você vai ter que abrir na tela, correr o cursor, todo mundo lá impaciente para entender essa operação de busca. E aqui a gente tem tudo isso sumarizado. Essa figura, inclusive, está lá no meu livro, Planejamento, Controle de Obras, é a última figura do livro, lá no capítulo 20. Move on, James, please. Aqui. Isso aqui é o metrô da linha 6 de São Paulo. Você consegue entender aí onde a obra vai começar? A parte de escavação da via, que é a parte inclinada, exatamente essa linha vermelha. Se você olhar, ó, aqui tem dois tatuzões, o TBM, a tuneladora. Vai sair uma para a direita e vai sair uma para a esquerda. Se você olhar, a declividade dessas duas linhas é diferente. Por quê? É por causa do solo. Se você olhar o da esquerda, está indo para um solo vermelho. O da direita está indo para um solo que começa em bege, né? Então, tudo isso está calibrado aí no planejamento de acordo com essas informações. As barras verticais amarelas são os trabalhos feitos nas estações, tá? Essa parte colorida que você vê aí são depois serviços dentro do túnel, a parte rosa, a parte roxa e a parte azul. Aí é pavimentar puxar sistemas ao longo do túnel, fazer essa parte de saídas, etc., de guarda-reio, né, para pedestre, esse tipo de coisa. Então, muito visualmente você tem. Me mandaram uma pergunta aqui sobre se essa ferramenta pode ser usada no caso de uma reivindicação contratual. Não só pode, como deve. Porque aqui, veja só, você pode botar na frente de um perito, de um juiz, de um árbitro, essa folha e depois uma outra de como as coisas aconteceram. E você pode dizer, veja que aqui eu não pude trabalhar porque eu não tive acesso, então aqui a produtividade foi muito baixa, aqui eu consegui recuperar a produtividade. Essa ferramenta, você jogando com essas linhas, você consegue facilmente cotejar o previsto com o realizado. Isso serve para reivindicações contratuais, tanto para você fazer como para você rebater, né? Serve para você apresentar à equipe no início da obra, serve para você mostrar a um cliente. Tinha até uma pergunta, no caso aqui do edifício, que James mostrou lá atrás, que ali todas as atividades estavam mais ou menos paralelas. Aquilo é porque ele fez o que se chama de balanceamento das operações. Ali ele fez uma conta de tal forma que cada atividade durasse a mesma quantidade de dias por pavimento. Se não for assim, as barras terão inclinações distintas. Is this the last slide, James? Ok. Aqui vocês podem ver, isso é um caso real que eu estava usando aqui. A linha sólida é o previsto, é como nós estávamos fazendo. Por que ela tem 3 declividades? Porque a escavação desse túnel, não era com tatuzão, era com explosivo, atingiria 3 tipos geológicos, cada qual com a sua produtividade de avanço. Então, eu mostrei. E o tracejado é como, na verdade, a obra andou. Se você olhar o tracejado, tem um período ali, a partir ali da estação 800, da progressiva 900, que ficou parada a obra, certo? Isso aí pode ter sido um problema na máquina, ou pode ter sido um problema do cliente, mandou eu parar para rever o projeto. Bom, o fato aqui não importa. O que importa é que eu mostrei aqui, de uma forma visual, tudo o que ocorreu no histórico do avanço daquele túnel naquela obra. Isso aqui, óbvio, vem acompanhado da narrativa, das explicações, do porquê as coisas aconteceram. Mas eu consigo mostrar aqui quando houve interrupções, os melhores períodos de produtividade, quando é que a produtividade mudou. Mudou foi por causa da geologia ou mudou por causa da curva de aprendizado? Tudo isso eu consigo fazer, então, um cruzamento das informações, dos dados, com essa ferramenta gráfica aí. Go ahead, please, James.
Okay, so here is an example where you have a project that the alignment is not actually a straight line, and you have a curve alignment like this on the map. This is my current project that I'm working on. And you know, if you imagine putting a map like this next to a linear schedule and you have a curve, then it gets difficult to plot along this because it's not actually a straight axis, right? Some of your stationing is this way, and on the chart that would get messy. So what I've done is I've turned this curved alignment into a straight line diagram where I stretch it out from the start at I-5 to the finish up here by Route 520. And I've put all the crossings, all the different bridges that are going over this highway or under this highway, under crossings. And so using this diagram now, I can plot a linear schedule of our work relative to this alignment. And I have our stationing listed here. Our contractor has broken all the work into different construction segments. I've listed those here. So what I'm working on now is building a linear schedule for this project using this as my primary axis to plot the work. Aldo.
Yes. And this is something that many people ask me, can I do a line of balance or a tempo caminho no project? Olha aqui, isso aqui foi um edifício feito de forma tradicional aí no project, só que veja que aqui a gente vai ao contrário, né? Primeiro pavimento, segundo pavimento, terceiro pavimento e move on, James. Isso aqui eu fiz no MS Project para ver que dá sim para fazer, mas é uma trabalheira grande aí. E você vê aí as atividades, né? Nesse caso aí, elas não estão balanceadas. Tem atividades cuja produtividade, né, a duração por andar é muito mais reduzida do que outras, fazendo com que ela tenha uma linha mais em pé, mais íngreme, mais vertical. Mas aí a gente vê tudo. O que eu acho é o seguinte, isso aqui no MS Project você consegue fazer, mas o que você não tem aqui de outras ferramentas é o aspecto visual, como a gente viu, né? Você plotar a estrada, o edifício, a adutora, o gasoduto, o metrô, que a outra plataforma tem. Então, o que muitas vezes eu recomendo é que se você gosta de trabalhar no project, você pode fazer e depois exportar. Aí não precisa chegar nesse nível aqui, lá com as atividades mesmo, você já exporta para uma ferramenta. Aí, por exemplo, a Graphic Schedule. James, I have a question for you. How detailed does your bar chart needs to be in order for you to export to Graphic Schedule? Do you need the summary tasks, or you have to take one by one in a very detailed way?
So what people usually do with a linear schedule is develop summary activities to show how the work is grouped and how things move over time. Our tool, Graphic Schedule, uses the activity ID to define the start date and one more activity ID to define the finish date of whatever shape you want to draw. So if you have a line that moves along your project, you would pick one ID to start the line and another ID to finish the line, and then the shape is now linked to those activity IDs so that if the schedule changes, the dates will update automatically.
Right. And how does Graphic Schedule? Do you have another screen, another slide?
I do. I don't have a screenshot of the software in here. I could easily turn it on. I like to tell people that they don't always need software. They could also try just drawing one to start and see if they like the format, to try it on a whiteboard or a napkin.
I have a question from one of the attendees. Is it very hard for a person who is used to Primavera or to MS Project to think in a linear scheduling way? I don't think so. It took me one day to become used to linear schedule. And whenever I personally get involved with a linear a schedule, the first thing I have in mind is I need to work with a time location schedule, because for me it's much useful and easy, and it's very it's easier to detect clashes, right? To detect problems in crossing activities and in long flows. What's your opinion about that, and the opinions of people who work with linear scheduling, James?
Yeah, so what we've heard and what we've experienced on projects is the schedulers appreciate having another way to look at their data. So we're not recommending that you no longer need P6 or project. Those tools are essential to deliver a project. Every project needs a CPM schedule. But the linear schedule is another way to look at it. And most of the time when we show a linear schedule to the scheduler or to the owner, as they look at it for a second, then they kind of have a aha moment, like, oh, wow, now I understand it. Now I can see it. And so it's very complementary to the tools that you already use to schedule a project.
Can you load resources into graphic schedule, James?
No, we can't. Our tool is fairly simple. It just runs inside of Excel, and this table here is the list of the shapes that you create, and you pick a color. So you can use color to define, to kind of, your tunneling crew is green, right? Or your shaft crew is blue, right? These are, you can use colors to identify the type of resource, but that it's not linked into resources from P6. It's just shapes and colors. And as I said, you can add links by activity ID to define your dates.
Right. One of the attendees here, I met him in a project in Trinidad Tobago in the Caribbean, and he was a young planning engineer, and my task as a consultant was to validate the schedule of the contractor. Okay, and so he showed me 5,000 activities, and I said, oh Jesus, what can I do to validate this? And then I asked him, let's make a linear schedule with the information that you have here. And then we didn't have any software, we didn't have graphic schedule, we didn't have any other software. So I did that in Excel. I told him, let's go, excavation, what are the dates? And then I started to draw lines in Excel, and we realized that the schedule didn't make any sense, because sometimes you had the base, the sub-base, then the base, and only 6 months later, you would have the asphalt paving. And that's not realistic. Do you agree with me? Você tinha lá a base sendo feita e a pavimentação asfáltica só ia ser feita 6 meses depois do período de chuva, inclusive. Então, quer dizer, aquele cronograma, que aparentemente estava bem feito, aparentemente estava lógico, quando nós jogamos no formato de tempo-caminho, ele se mostrou assim deficiente, ou pouco adequado à maneira como a construtora iria, de fato, fazer a obra. Então, essa é a mensagem aí, que vocês, tendo uma obra linear, James, can we use it in a water sanitation project, for example, that has many branches? I know that the answer is yes, but what do you say?
Yeah, I would say that if you have a complex facilities sort of project, like water treatment or a power plant or a school or things like that, those are difficult to plot on a linear schedule because they don't have an axis along alignment, right? However,
right.
The concept of plotting your work by location can still be applied to communicate a project like that. For example,
yes,
let's say you had a treatment plant with 10 different basins that each were their own kind of system, right? You could have one row for each of them and group your activities on that row for each basin. And so that is not exactly a linear schedule, but plotting it using this axis to kind of group it by the tank number, it would be a nice way to look at the schedule, right? So
this road project that I mentioned, it was not just one road, it was a road and then like a tree, alguns ramais. And for each one of these branches, para cada desses ramais, eu preparei pequeno tempo-caminho, que depois ele se encaixava no tempo-caminho geral, entendeu? Isso é muito interessante. Bom, nós estamos respondendo, we are answering the questions that Mike is sending to me. There are questions about my books. Let's put them aside. James showed us where the project was not strictly linear. Yes, it can be a curved line, but if it has a displacement of the crews, se existe fluxo, trajeto, não precisa ser necessariamente uma rodovia em linha reta, pode ser uma rodovia que faz curva também, né? Uma ferrovia. Is there any connection of linear scheduling to BIM? Do you know, James?
Not exactly linear scheduling. There is something that's sort of similar called 4D scheduling, and that uses a tool called Synchro, and there may be some others now like it, where you can have a model in 3D that is tied to your schedule. And basically each shape in the model is also linked to activity ID, kind of like what we're doing. And you can basically click play and watch the model be built over time as each activity in the schedule happens. So people are using tools like that, especially a lot more in the vertical construction space, I would say, not as frequently used in horizontal construction like roadways and things, but that is out there, and they call it 4D scheduling.
Yes, yeah, the 4D scheduling. Some people are asking about software. Well, you have graphic schedule, which is the one developed by James, but you also have Tilus, programa alemão, Tilus, da Linear Project. Você tem o Turbo Chart, Time Chained Chart, Time Location Plus. Você tem vários aí em todo tipo de sofisticação, de preço, de licenciamento. O importante é você entender qual é o benefício. It's important to understand the benefit of this kind of linear schedule. And I hope that all the attendees understood what it is about and the importance of showing the schedule in a more visually attractive way, de uma maneira mais atraente visualmente. Well, what time is it, Monte? It's about 3 o'clock. I think we are almost done. And,
yes, it's 3 o'clock.
I have seen people here saying that they have worked with this before and they enjoyed.
There is a lot of questions. I don't know how much you'd like to answer alive with James. Feel free, Aldo.
Yes, I'm answering most of the questions that you sent to me. There are comments. There are comments about books, comments about work, about projects. And James, what is your software more used by contractors or by owners? Seu produto é mais utilizado pelas construtoras ou pelos contratantes?
Good question. We actually find that both types of organizations are using the tool. And not only our tool, but other software as well. And the contractors are using it as a little bit more of that check, like you mentioned, to see how their plan looks, and using it as more of a planning tool. And owners, I would say, use it as a little bit more of a reporting and communication tool to help the project stakeholders get a better understanding of the project. So we definitely see both types of organizations use it.
Yeah, well, there are some people asking here, how do you get information from graphic schedule to go to the cost estimate? I think it's the opposite. É ao contrário, você precisa ter o orçamento para você saber qual é a produtividade que você está atribuindo àquelas crews, aquelas equipes. Uma vez determinado lá no orçamento qual é a produtividade com a qual você está trabalhando, é que você traz essa informação, e essa informação é que é desenhada, vamos dizer assim, no gráfico. A inclinação da linha é exatamente essa produtividade, a representação visual dessa produtividade que o programa aqui foi beber de lá do orçamento. There's another question. How do we work with quantities? Well, quantities with production rates become duration, right? This is the basic formula. And the duration then is plotted in the schedule with this line. The line shows exactly the production rate. So the duration for each portion of the project which is being built. James, can I share your contacts with the attendees in case they want to know more about the graphic schedule?
Absolutely. Yeah, the easiest way to reach me is my email address. It's james@graphicschedule.com. We have a website, and I'm also on LinkedIn. Happy to connect with anyone on LinkedIn.
That's excellent. And can we share these slides, or are they protected?
These slides are okay to include in the recorded webinar. And if anyone wants to get a copy, you can email, and I will send it to you with an email. Yeah.
Right. Excellent. Well, it's 3 o'clock now, and I think we covered the scope that we intended to present. E eu queria agradecer a todos que participaram. O meu livro, Planejamento e Controle de Obras, trata desse assunto no último capítulo, é o capítulo 20. O livro, Como Preparar Orçamento de Obra, na terceira edição, teve inclusões de assuntos em relação à segunda edição. O Planejamento e Controle de Obras, muito pouca coisa, tá? Respondendo aqui a um colega. Eu agradeço a todos aí que ficaram durante essa hora conosco, foi um grande prazer. Espero que tenha sido interessante, espero que tenha sido ilustrativo, como a técnica bem é. E se vocês tiverem mais perguntas, por favor, mandem a Maitê, não dá para responder todas, porque tem inclusive perguntas que são redundantes. E agradecer também a aqueles colegas aí que se manifestaram, mandando perguntas, mandando comentários. Tem colegas aqui que trabalharam, inclusive, nesse projeto aí de Trinidad e Tobago. E thanks, James, and your final words, please.
I just enjoyed being with you all today and appreciate all your great questions. And thanks again to Aldo and Mady and everyone for inviting me to join you today. I wish you all the best on your projects.
Thank you, James. Thank you all.